All right, guys, so we're going to look at a couple examples from this worksheet. Just a short little video to help you with a few things, specifically when we get to the word problem parts. 1 through 4, you are asked to determine whether the set of numbers are Pythagorean triple. So for each one, you want to first make sure you have A, B, and C, and then very simple, does A squared plus B squared give you, or does A squared plus B squared give you the same value as C squared? So I like to do them as two separate problems. 9 squared plus 12 squared, you have 81 plus 144, that is 225. 15 squared, also 225, they are equal. Yes, this is a Pythagorean triple. That's simple, guys. And for each problem, it's either yes or no. If the two numbers are the same, yes. If they're different, no. On here, do make sure that you put them in order. So like on number 2, make sure that you realize 5 is A, 12 is B, and 14 is C. Okay? But I think y'all can do the rest of those on your own. So let me clear this out. All right, for 5 through 8, it says tell whether the given triangle, or the sides basically have an acute, obtuse right, and also from your notes. So really we want to start in the same way we did 1 through 4. You have A, B, C, and it's pretty much the same process. It's just if they're not equal, then you can also determine if it's acute or obtuse. So 18 squared plus 13 squared, you get 233. 15 squared is 225. So obviously not equal, so not a right triangle. But now you got to look. A squared plus B squared is bigger. Okay, if you look at your notes, when A squared plus B squared has a bigger value than C squared by itself, that is acute. Okay, and that's all you're doing. If they're not equal, then you have to determine which is bigger. So again, if A squared plus B squared is bigger, it's acute. If C squared by itself is a bigger number, that's obtuse. And then if they're equal, that's a right triangle. So those are your 3 choices. Okay, pretty simple there. All right, and then for 9 through 14, you're finding Pythagorean theorem, or using it to solve for x. Pretty straightforward there. A couple little things here. Obviously, this breaks up into 4 and 4. On number 12, you have to do Pythagorean theorem twice. First, to find that diagonal with 9 squared and 12 squared. That'll give you a value. And then you find that, and you do Pythagorean theorem again with that right triangle. So you find the hypotenuse here. That gives you a value. Then you use that in the second one. So Pythagorean theorem twice, not really a big deal. So if you can use simplest radical form, I'll look at answers at both decimals and in that form so we can get used to that. All right, moving on to the word problems. 15 shouldn't be that difficult. Basically, it says you have a ship leaving the dock. So, here's the dock. It goes 6 miles due north, 4 miles due east. There's your ship. And which of these helps you find the distance from the dock to the ship? So obviously right triangle, Pythagorean theorem, if you look the way that it sets up. Now, theoretically, you should have A, B, C. But in all honesty, and I'm going to give you a hint here, it's okay if A and B get switched because it doesn't really change what you do. So if you have that A and you have that B, I didn't mean to do that. As I was saying, it doesn't matter if they switch up and this becomes B and this becomes A because you're still solving for C. Okay? So now we go down to number 16, and it looks a little confusing, but it tells you that the original pole before it was broken was 25 feet. Now it sits like that. How do you find it? Well, it's a very simple process. If you think about the pole was originally 25 feet and it broke. So how's the only way to write the hypotenuse as a length? 25 minus x. Because this is x feet, the rest of it is that, to get 25. So, you're going to set up a problem. At first, it looks kind of complicated. It's x squared plus 15 squared equals 25 minus x squared. You got to do quadratic. The only good thing is you have multiple choice answers. Plug them in. See which one works the best. That would be the easiest thing to do here. All right, this is the back of the worksheet from today. Just go through it real quick. Just a couple word problems. Really not too difficult on this side, except maybe number 20. Number 17 is one of those problems we see a lot when it comes to this section, the ladder leaning against the wall. Just very simply because it sets up a right triangle. So nothing super complicated here. 25-foot ladder is leaning against a wall. So draw yourself a wall. Here's a ladder. It's 25 feet long. The base of the ladder is 6 feet from the wall. So to the base to the wall is 6 feet. They want to know how high up the wall does it touch, so you're looking for the height. Right? So pretty simple Pythagorean theorem problem. 6 squared plus b squared or x squared, however you want to write that, equals 25 squared. And that's all you're doing there. Number 18, word problem. Just really pay attention to the picture, mainly because of the bottom here. It doesn't talk about the extra 166 feet there, but if you look at the picture, that's clearly going to be your base, if you will, A or B, whichever you use. So add that together. You do get 666 feet, plus x squared equals 985 feet. Okay, so again, Pythagorean theorem problem, pretty simple. I did not make up those numbers, by the way. And then on the last problem, if a right triangle has two sides of length 1 and square root of 3, which of the following could be the length of the third side? So really what I would recommend you do is figure out what the square root of some of these numbers are. For instance, the square root of 3 is about 1.732. The square root of 2 is about 1.414. And the square root of 5 is about 2.236. So you have to use 1 and 2. 1 in the square root of 3, and you have to decide if the third side fits. So for instance, if you had 1 square root of 2 square root of 3, you realize, or you should realize, that you're looking at 1 squared plus the square root of 2 squared equals the square root of 3 squared. So even though 1 and square root of 3 are part of it, that square root of 3 would have to be c because it's the bigger number. This gives you 1 plus 2 because the square root, or the square of a square root numbers, these cancel out. So in other words, when you take the square root of something, or square something that's being square rooted, that cancels each other out. You're left with just the number. So that's also going to give you 3, and 1 plus 2 is 3. So 1 works, and then you go back and do the exact same thing for the other combinations as well. All right, so I cleared that out. So, for 1 and 2, you have 1 squared plus the square root of 3 squared equals 2 squared. Again, 1 plus 3, and 2 squared is 4. 1 plus 3 is 4, so 1 and 2 work. Maybe erasing will be easier than crossing the whole thing out. And then for the last one, the square root of 5, obviously going to be the biggest number. So again, you have 1 squared plus the square root of 3 squared equals the square root of 5 squared. But since we know how that works, 1 plus 3 equals 5, and that actually does not equal each other. So it's only 1 and 2, so I guess I'll help you with that one. That's C. All right, hope these videos help. We'll check this tomorrow in class. Good luck.